All right, well, good morning, folks. My name is Cameron Nixon, and welcome back to Mesoscale Musings. Today is Saturday, May 30th of 2020, and in typical late May fashion, we are dealing with a level 3 of 5 severe weather risk from Oregon into Washington. So, sarcasm aside, I figured we would discuss why this is happening in this area and what kind of severe weather hazards might present themselves. So right off the bat, you can see this pretty snazzy looking upper level circulation here. You don't need any upper air maps to tell you that this thing is indeed spinning, and this is going to be our weather maker for today. You can see on the kind of northern edge of this, there's some forced synoptic lift in the form of kind of the stratiform precipitation. And obviously the terrain features are also probably helping here with that lift. You could also see the beginnings of some more discrete cellular activity here, so today might already be beginning. So if we take a look at our 12Z observed soundings, this is a few hours ago, take a look at Medford, Oregon first. You have some pretty steep upper level lapse rates here, and some elevated instability. So why is this elevated? What's going on here? I looked at this for a little bit and I was stumped at first, but then I realized I'm going to have to type this in and cheat. Where are we here? Where we're launching the sounding is nestled in between all these high terrain features. There's literally a mountain here, and all the greenness, this lushness, is the tops of our higher terrain. So where was I? So while you are launching the balloon from the surface, which is near sea level, it's 405 meters. Once you work your way to the top of these terrain features, you're standing right about here, and there's a lot of instability right above your head. This is while it's elevated instability where you launched it, it's pretty much near surface instability once you get to the top of these features, which is why you're probably getting convection already, even though it's quite early on top of these mountains, since things were basically supportive of convection immediately on top of these things. So if we go to Portland, you can see kind of the same deal. It's a little bit drier up here. This is kind of going to be a theme for the rest of the day, but we have those 8.3 Celsius per kilometer lapse rates here. It's pretty steep. And we still have that elevated instability, which again is surface-based instability once you get on top of those terrain features. Another common theme of today is going to be our photographs. Very nice. We got some northerly surface flow extending to some southerly upper level flow. So this is going to make for some pretty lengthy straight photographs, supportive of robust supercells, especially with all that kind of off the deck around 1 kilometer to 4 or 5 kilometers here. This is what I love to see for some pretty long-lived robust supercells capable of swaths of severe weather. So we can let's dig a little bit into why we're getting severe weather today. Obviously, our weird orientation of the jet. And if we throw up some station plots and get that rain out of here, we have some mid-60s dew points, kind of just in a little region here between the Washington and Oregon border. So why is this? Why are these here? So these dew points are kind of channeled into the Columbia River Valley. You can see here is generally some lush farmland here close to the river. Again, this kind of makes up the border between the two states here. And so this is where dew points are going to generally or preferentially lies are in these lowlands. So let's talk about the rest of the area then. Why don't we get severe weather in this area very often? And it has everything to do with this higher terrain out here between the Pacific Ocean and this basin here. So most of these are the Cascades. They're roughly 5,000 feet tall, most of them. So you're in our typical weather pattern. Again, we have west to east flow in this part of the hemisphere. And in our typical weather, we got that strong jet coming through here. It is going to downslope from these mountains into this basin. So this can, I guess, take on some generally arid or more arid conditions here, especially than west of these. Because we're basically getting all the lift here west of the mountains, raining itself out as we go here. We're becoming more dry adiabatic as we downslope, and we're mixing out our near surface moisture. So you're not going to retain the moisture that you had from the Pacific Ocean, at least near the ground. So that being said, when you have a nice strong system come through, that usually should lead to some drier air and sunny skies, or at least maybe some cirrus-filled skies over here. So not generally supportive. But what if we had a jet that moved from the south and toward the north? So a southerly jet up in the upper levels. We have a significantly less component of strong downslope flow. It's a little bit more gradual. These are still approaching 5,000 feet here. And you do have a steep upslope here. It's nothing like the hard slopes here, but you do go from near sea level under 1,000 feet to about 4,000, 5,000 feet in a relatively short amount of time. So this kind of regime here is almost like if you're going into northeast Colorado, but quite a bit more abrupt, I guess. But this is a similar elevation. So then if you go to the northerly fringes of this basin, the Columbia River Basin, it ends up being roughly 1 to 2,500 feet here. This is the Columbia Plateau. So again, this is kind of a little bit more like western Kansas in terms of elevation. But this is kind of how this area works, and I guess when most of our jet streams suppress severe weather, we need something like this really amplified weird pattern here with some moisture already in here to start a severe weather event. So let's discuss. Did we look at? Okay, yeah, we didn't look at Spokane, Washington. There we go. They're sounding it. So. As it differs from Portland, you can see we still have that strong elevated instability and that potential for that cape there. Nearly dry adiabatic lapse rates in the mid-levels as well. But our low to mid-level moisture definitely takes a hit here. You can see even though we have 54 dew points, it's definitely a lot drier in the low mid levels, so this is going to be less supportive for robust convection unless we make this a little bit more moist, which I'm not sure is going to be possible today because once we do have this system raging in here, coupled between our left exit and our right entrance region, we're going to build a low pressure system, this is how REP determines it will evolve. So this makes a lot of sense synoptically, but we're going to have a lot of downsloping flow once this all begins. From these upper low or these kind of higher terrain features into this river basin. So again, it's favorable for severe weather, but not entirely favorable of severe weather. And I figure that this kind of profile might perpetuate a little bit throughout the day. But there are going to be some isolated areas that are more favorable. So let's discuss let's try to make the wonkiness of the surface pattern a little bit more understandable. So again, you have a low pressure building here throughout the day. And if we move to dew points, you can see this is the kind of pocket or pool of dew points. Even looks to be a little bit potentially underdone. I remember seeing a 66 in there. But again, this is really complex with regards to terrain. And we have very sparse surface obs here. So it is not a surprise that things are not going to go exactly as we think they will today because of our sparse observation network there. The models are trying their best. So if we look at theta E, basically just measuring our moisture content, We see that we have a Pacific front. Again, this is usually called dry line as it moves into the U.S. Or the central U.S., but we're literally getting it directly from the horse's mouth. This is our Pacific air. Starts forming kind of midday. This might help to trigger some of our convection as it is going on right now over the higher terrain. You can definitely see our swirly here. As that low strengthens, you might get some of that moisture to filter up, kind of upslope. Again, this is kind of like your Northeast Colorado setup. You're just filtering in those dew points up there. So that's going to help here. But again, the area of highest dew points is not necessarily going to be the area most favorable for convection. So we have our kind of Pacific front here, and I guess you could almost call this like a effective warm front. These are the Cascades here, but you can't have anything north of this because they're mountains. And then we have a more kind of mountainous region here. So we're really chopping off our favorable area to this kind of like sliver here. So let's trace out how this might look. Let's take a 18Z, kind of more current, kind of over the top of this terrain. Again, you could see what we were kind of hypothesizing could be happening here over some of our higher terrain features, is that we do have steep low-level lapse rates near the ground, even though we didn't when we actually launched the sounding. So this is going to lead to some pretty quick development of convection here. So we got 73 over 52, so still some decently high LCLs, but we still have some nice CAPE in the low to mid levels. And again, our photographs look like they were when they were observed, roughly more stationary or weak, calm surface flow, even though you have some pretty rocking upper level jets here. So again, this is 38 knots of 0 to 3, and what makes it even more impressive is that our 1 kilometer is basically where your 0 is, so this is 38 knots of shear just from 1 to 3 kilometers. So this is what I really love to see for some pretty robust, long-lived supercells capable of swaths of severe weather at times. So pretty decent sounding for severe weather for this area. And if we take it out another hour, or 3 hours, you could see our CAPE start steadily increasing. This is a little bit contaminated. I don't know how much better we're going to do with all this weird. Yeah, there we go. Still got that pretty thick CAPE here with all those steep lapse rates here as we get into our higher dew points near that river basin. And again, really long photographs on the low levels, so pretty favorable for supercells. So my only wonders here are, especially in the beginning, we're initiating off of this kind of lumpy terrain here. There's not I guess like an acute focus for severe weather, so I'm wondering if we start initiating a little bit too much. There's a little bit too much competition here, and we have those relatively higher LCLs. So our initial activity could be quite robust, especially because we have a lot of near surface CAPE. But I'm guessing this might be the first to kind of start blobbing out, perhaps not immediately kind of line out, but at least start growing upscale in some fashion before it hits kind of the river here. So around this 21Z hour is when I would think this convection starts becoming stale that initiated first, in the sense that it might not be supercellular anymore, and change that threat for mostly severe hail into perhaps mostly severe wind. So at our 21Z hour though, as you get later on in the day, if you look at the surface map again, we're going to be funneling that moisture up into the higher terrain here. And you can see there are some pretty higher peaks here. Again, this is kind of muddied terrain. There's not a clear focus, but I don't see why, if we don't have a persistent northerly flow up against these mountains, we couldn't initiate something, especially maybe around here, where it's a little bit more moist in the low levels. So this would kind of be your kind of tail end Charlie storm, and I would think this would kind of form as the other convection starts getting stale and might kind of steal the show and kind of remain ahead of them for long enough to become a relatively longer-lived supercell. So poking a sounding somewhere near here, again, this is heavily terrain influenced, but the general idea is still there. This is definitely a photograph I haven't even been used to. So a lot of weird stuff going on here. Let's see if I can pluck another one. Yeah, so things are changing very heavily in these mountains. So take these what you will. But again, this cape is quite nice. Assisted by our high low-level dew points. We start getting some impacts of some dry air in the mid-levels, but still should be supportive for the quick growth of supercells here. And if we scoot out to 0Z and just pluck one in the middle here, again, once you start getting in the valley, you'd think you'd be better with those 65 dew points, but you have a lot higher LCLs. You have a really high, it's reaching almost 90 here in the center of that valley. So any tail end Charlie cell is really not going to like it once it makes it into Washington, and could definitely just start auto lining out even if it was an organized supercell. So especially this deep of a dry layer here, even with all that cape, it's just going to be pretty hard to sustain persistent rotating updraft, and will really start kind of gusting out. So other models have hinted at the possibility of more convection initiating off here, but generally as you move into the nighttime hours, late evening hours for this area, the favorable instability keeps riding up north toward the Canadian border, and you still get this really deep dry layer here, so the threat should really become just a damaging wind, and perhaps a pretty widespread damaging wind event given the convective organization here into the later afternoon, evening hours. So that's kind of what I expect for today. I hope you guys enjoyed this. I know I enjoyed the explanation or exploration into what kind of terrain features do what over here. And again, I'm not a native, so I don't claim to know everything here, but it at least was refreshing to kind of dig into this a little bit. So I hope you enjoyed this, and I'm looking forward to seeing what happens today. Have a good one, folks.